welcome to this math review video on the definition of a parabola. So, what is a parabola? A parabola is defined as the graph of all points that are equidistant from a certain point and a certain line. So in this example here, this curvy shape, which is our parabola, is all the points that are equidistant from this point and this line. So this segment, which is the distance from, say, that point right there to this line, and the distance from that point to that point, this segment, are the same, and as well as over here. These have the same lengths. So let's investigate a little bit more. So say we are tasked with finding 3 points on the parabola between the point 0, 8 and the line y equals 2. So for every parabola where you have a point and a horizontal or vertical line, there are 3 principal points that are very easy to find on that parabola. So for here, this first principal point is pretty obvious. It's right here, because this distance is 3, and this distance, which is the shortest distance from here to here, because it's on the perpendicular, is also 3. So here's our first point that is equidistant to both of them. And now our other 2 principal points are pretty easy to find as well, and they're pretty similar to each other. So since the distance from the point and the line is 6 units, if we come over here 6 units away from our original point, moving parallel to our line, then we will have a point that is both 6 units from the original point and also 6 units to our line, because the perpendicular distance is still 6. And then we can do the exact same thing over here, moving 6 units that way and still 6 units from the line. So now we have our 3 principal points, and we can take a guess at what the shape of our parabola looks like. Probably looks like that, and it goes through those 3 points. Alright, so now let's find the equation for the actual parabola between the point 3, 5 and the line x equals -1. So we'll call a point on our parabola x, y. So first, we need to find the distance between the point 3, 5 and x, y. And so to do that, we're going to use the distance formula. And quite simply, this distance is the square root of y minus 5 squared plus x minus 3 squared, because that is the difference in y and the difference in x squared, and then the square root of that all. So that is the equation for the red segment, and for the blue segment, it's much more simple. The distance between our point and this line, since this needs to be perpendicular, is simply going to be the x coordinate of our x minus y minus the equation of our line, which is -1, or, put more simply, x plus 1. So now, to get the equation, we simply have our 2 distances, this one and this one, and then we simply set them equal to each other. And then if we do some algebra, we'll come out with a reduced equation, which I'll put in the input bar, and then we can take a look, and there's the parabola. And as you can see, it goes through the principal points, which are right here, whoops, there, and there. Alright, so it's time for a recap and then a quick little side note. So, by doing the distance formula between the point on the parabola and then finding out the horizontal and or vertical distance between the point and the line, we get the equation for our parabola, which looks something like this, and that in this case can be reduced down to this. So an interesting way of visualizing a parabola is with a circle and another line. So let's make a circle with the center at our point and with the radius of a variable a. So this shows all the points that are a units away from our point. And then we can make another line, which in this case would be equal to x equals a minus 1. That shows all the points that are a units away from our line here. So then, if we find where these two intersect and we change A, we can watch the points where the line and the circle intersect, again, which means it's equidistant from here and here. We can see it trace the outline of our parabola. Thank you for watching.